Okay, Bismillahirrahmanirrahim. Say it. So we go to the next topics where we have the estimates, we have the margin of error, and most important topic is confidence interval. Confidence interval. So what is this confidence interval and all? Do we have a pen which is a little fat? इसका मोटा पेन कैसे होता है इससे? No. Anyways, leave it. Here it is the color red and maybe the fat one. Yeah. So confidence interval. Okay. Say for let's work out with an example. Say for example, we are having a population. Say for example, the India. Okay. In the whole of the India, we are trying to see what is the average weight of the newborn baby. Average weight of what? Average weight of newborn baby. So what I'm gonna do is, because we know average is that you sum up all the guys and divide it by n, right? But is it possible to sum each and every kid in the whole population? That's not possible. Is that how you do? No, that's not possible. Even if we do start counting, every day around 70,000 babies are born every day. So even you have started, the new 70,000s are born. So it's not possible. So we can't in any kind of population. We don't work on a population. Then we work on what? We work on samples. We work on what? Say we have the whole population. We don't take the whole population. That's not possible because it's a huge. So how to do it? We want to find the population parameters. Population. So if you want to find the population parameters, like we have the mean, we have the median, we have the variance, and then maybe the covariance and all. Any population, population like variance we have, or like we have the mean and all. If you want to do that, so we don't take the whole population, we rather take the samples. We take what? So from this whole population, say this population was like 10k, we are taking like 50 samples. But we don't take just one sample, we take many of the samples. Okay? Because if we just take one sample, maybe it was wrong, we took a wrong sample. Okay? Maybe we took a people which was having extreme things in that. So we have to take multiple samples and check out the means then. But obviously the mean of the population, won't be same as the mean of the sample. But if you take a lot of samples, then we have a techniques that our mean of a sample will come closer to the mean of population, but will not be exactly. We know that there will be what? The error, the sampling error. There will be sampling error also. Okay, that's also called the margin of error. There is a margin of error. There is what? There is a margin of error. MOE. There is a margin of error. Why? Because these samples may not get 100% exact, mean, which was of the whole population. So what are we trying to do is this is called as an estimate. We try to estimate. We try to what? So this estimation we are doing. Next page. What are the pages? Is this a? Here is the pages, no? So this is called an estimate. It's called what? So estimates are of two types. Either there is a point estimate, or there is a range estimate. Okay? We have a range. Where are you grabbing it? You can tilt it. Yeah. So point estimate and range estimate. So we want to find a point estimate, like we want to find the mean. We want to find what? So mean definitely will be the point estimate if you say the mean. So you have some sort of a variables and you see the middle point. Okay, you add all the things and divide it by the n and you get the mean. You are getting exactly the point. Okay, you are saying, like, for example, average weight of newborn babies is, for example, 3.2 kgs. Now this is the average weight, or this is the mean, which is telling me one single point. But when we take the samples, when we take what? You are not concentrating. Concentrate properly, listen what I am saying. Try to understand the concept, because I am building the concept. Okay? But if you see left and right, your brain is somewhere, you may not be able to understand. Otherwise, very simple thing. Just concentrate, give these few minutes 100% to the board. Now, because if we do the sampling and we get the mean, okay, it may not be the exactly population mean. There will be some kind of a margin of error. So the point of estimation is not an exact thing. Because there may be, we are off track a little bit. हमने 3 point, say for example 2.5 निकाला था, इसको आधा kg उधर है, आधा kg इधर हो सकता है. So my mean, if I say my normal distribution, and I will see the normal distribution of my population, of my sample, if I say normal distribution, say the mean was here, of the population, we say normal distribution of population. This is normal distribution what? We have seen the normal distribution, Gaussian, the bell-shaped curve. The normal distribution of population. And we know this is exactly here, the mean is here. But maybe our mean जो हम निकाल रहे हैं, it could be in this range. It could be in this, say from here to here. There is a great chance that our mean will come in these areas. Somewhere here in the bell, somewhere under the bell. So it could be from this low area, from this high area. Okay? So we cannot just get in sample and calculate its point estimation, and we say this is the estimation of population. No. We need to have some kind of a range. That's why we have the range estimation. We have what? And this range is called as confidence level. It's called as what? This is called the confidence level. This is called as, got it? What I'm saying? So what is confidence level? It is actually the point estimation. It has two things. How many things? So what is firstly the point estimation? What is point estimation? If I have to ask you, what is point estimation? Point estimation is a single way. Write down. Point estimation. Write down. Point estimation is a single value to calculate population parameters. What are the population parameters? Like we have the mean, or we may have the variance and all. We have the variance. So this is a single point, okay, where we want to calculate the single point. But if we say, we are saying that we have the mean, but that's not exact thing, because if we do the mean of a samples, that may not be exactly fitting, but there may be off track a little bit. Our means may be, because maybe my data is such that it is going from this side. My data is such that mean is going on this side. Because I am taking only samples, na? I am taking only what? Because I have a whole population, maybe in this class, which has maybe this class is 80 students, okay? And I want to see how class is scoring. I took a sample. Maybe I took a sample of only those students who score low. So मेरा mean तो इधर आ जाएगा ना, low side. Or maybe I take a sample of those students which are scoring very high. I take only the position holders in my sample. Okay, out of 80, I'm taking 10 of sample. I'm about 10 के 10 मैंने वैसे उठा दिए जिनको जो अच्छे पढ़ते हैं. तो उसका मीन तो इधर को आएगा ना, और मुझे लगेगा कि it will feel like कि class is going very good. और अगर मैंने 10 स्टूडेंट ऐसे उठाए जो कि बिल्कुल लो स्कोर कर रहे हैं, ठीक है? So the mean will give me the low scoring class. So it will not give the exact situation of the class. Got it? So I have to have some kind of a range. Okay? and I have to adjust my calculations as per the range. As per the, got it? What I'm trying to say? You getting? Okay. So that means, and if we say point estimation, the point estimation is a single value. And what about the range estimation? It has a range of values from low to high. Now, if I go to the confidence level, how to calculate this confidence, because this is called confidence level, that range, the range between here to here, this is my confidence level. This is my confidence level. Okay, confidence level means कि आप कितने, मतलब literally if I say, कि आप कितने confident हो कि आपका जो point estimation था, जो आपका क्या था, वो lie कर रहा है, say for 95% or 99% in this range. Okay, so this is how we calculate. Now question comes, how we calculate the confidence level. There is a formula. There is what? Okay. Now if we want to find the confidence level, that is equal to mean, we got the mean, plus minus, there is a Z value. Okay, the Z value is the confidence value, we say like 95%, 96%, 90% and so on. Okay, so Z value into standard deviation divided by under root of n. Okay, this is the formula. This is the, why plus minus? Plus minus is because if we have a normal distribution, this will be the confidence low, confidence level, low confidence level, and this is going to be high confidence level. Right? And this is my exactly the point estimation, the mean. The mean is here actually. That is the point estimation. That's what? Basically this formula is having two things, the point estimation and the range, and the margin of error. And the, so my, if I say technically my confidence level is equal to point estimation plus margin of error. MOE is margin of error. If you look at the formula, the X bar, what is the X bar? The mean. What is the mean? That is the point estimation. Because mean, अभी बताया ना मैंने, जब आप मीन निकालोगे तो आप सिंगल वैल्यू निकाल रहे हो ना कि भैया ये है, ये मीन है, दैट्स द पॉइंट एस्टिमेशन. और जो बाकी इसके साथ ये वाला चीज है, ये क्या है फिर? दिस इज द मार्जिन ऑफ एरर. दिस इज द मार्जिन ऑफ, आइदर इट विल बी प्लस और इट विल बी माइनस. प्लस इधर को, माइनस इधर को. यानी कि यहां पे अगर मैं देखूंगा, ये जो मेरा कॉन्फिडेंस लेवल है वो इसके बीच में निकलेगा, लो एंड हाई के बीच में, इस रेंज में निकलेगा. सो माई जो लो मेरा है, that will be equal to, ये जो यहां पे निकलेगा, that will be x bar minus z into standard deviation divided by under root of n. This is gonna be my low value. For my high value, it is gonna be x bar plus z times sigma under root of n, standard deviation by root n. Okay, what is standard deviation? कि आप कितना दूर भाग रहे हो अपने मीन से. So ये क्या है मुझे बताओ, ये क्या है फिर, ये वहां यहां पे, this is the x bar. This is what? So confidence level में दो चीजें हैं मेरे पास. एक तो मेरे पास point estimation है, that is my x bar, that's my mean, and कितना भाग रहा है मीन से इनके दरमियान, that is the margin of error. That's what? So that is why I am saying my confidence level is basically between the low confidence level to the high. And low वाला कैसे निकलेगा? माइनस करो, जो आपका मीन है उसमें माइनस करो ये सारा, और ये कैसे निकलेगा? जो मीन आपका है उसको प्लस करो इतना. स्टैंडर्ड डिविएशन वाज आल्सो दैट ना. स्टैंडर्ड डिविएशन, व्हाट इज स्टैंडर्ड डिविएशन मींस कि आपका मीन से कितना भाग रहा है, कितनी स्टैंडर्ड डिविएशन दूर है आपका. अगर यहां पे कोई पॉइंट है, ये पॉइंट कितना स्टैंडर्ड डिविएशन दूर है आपके मीन से. गॉट इट? सो नाउ इफ यू डू अ लिटिल प्रॉब्लम to solve a question, to do a little problem to understand it, we will create a problem. You will create a question yourself, just write the things, okay? Just the things that we have a newborn babies, okay, and we took a sample. We took a, so if we take a sample, that is my n of equal to 50. I took a sample of 50 newborn babies, because out of the whole 70,000 newborn babies, I took just a 50 sample of 50. Got it? Sample should be always greater than 30, otherwise it won't work. So I am taking the 50, that's a good thing. And I am seeing the average weight. I am seeing what? Average weight of a newborn baby is average weight. If I say average weight, what is that going to be? That's the point estimation. What is that? When I say it is an average weight, what is that? That is the mean. What is the point? That's the mean. That is. So that means X bar is equal to, say, for example, 3.2 kgs. That means I am in a population of all the newborn babies. I am choosing a sample size. I got a random variable of sample size of 50. I took a random variable from newborn babies of the whole population. I am taking 50 newborn babies. Got it? And then I am having the X bar, that is the mean, the average weight I am getting is 3.2 with a standard deviation of, say, 0.5 kg. The question will tell you, like this, the standard deviation of 0.5 kgs. Now I am writing directly the values. Okay? And then I should also get the Z, na? Because, okay, I should get the Z. I should get what? I should get the Z. So Z value is like, I'm saying, question will tell you the 95% the confidence value, confidence level or confidence value, that's the Z value. That's what? So if the Z is given as 95%, for example, you have to calculate its, write in the Google 95% Z value. Convert 95% Z value. Confidence level ही खुद ही देगा मेरे ख्याल से Google. What is the value? 1 point something, 1.96 है probably. हाँ? क्या देना है पूरा बताओ? कन्वर्ट किसने किया यूनिट में? हाँ? ना. 1.96 confidence level. 1.96 आएगा. That's equal to 1.96. ये क्वेश्चन में या तो दिया होगा या तो जबान याद रखो. 95%, 90% का 2 point something है. ठीक है? वो याद रखो. 90% का. टेबल आप देखो Z वैल्यू टेबल. Z वैल्यू टेबल निकालो, टेबल से देखना होता है. क्वेश्चन जो आपका है वो अक्सर परसेंटेज भी देता है, लेकिन वैल्यू निकालना है ना मैं ऐसे टू कैलकुलेट. Got it? So now let us see किस में आएगा हमारे पास ये. ठीक है? So हमारे पास पता है कि जो लो वैल्यू है ना वो कैसे आएगा? X bar minus Z into standard deviation divided by under root of n. Okay, this is my mean, this is less than this, and this is less than X bar minus plus Z into sigma divided by under root of n. क्योंकि मेरा जो X bar है that is given 3.2 kg, वो आना चाहिए इन दो वैल्यूज के बीच में. मैं रेंज निकालूंगा पूरी कॉन्फिडेंस लेवल की. अब करो इनको मल्टीपल से. X bar that is 50, mean is 50, है ना? Oh sorry, 3.2, sorry, mean is 30, that is n is 50. 3.2 रब कैसे हो रहा है? एक मिनट. Okay, we got 3.2 minus how much? Z times Z is 1.96 times standard deviation is how much? 0.5 divided by under root of, that is 50. Okay, calculate this value. And यहाँ से आएगा हमारे पास 3.2 minus या प्लस आएगा Z के वैल्यू है 1.96 times 0.5 divided by under root of 50. यहाँ पे सिर्फ प्लस करना है, वहां माइनस करना है 3.2 को. 3.2 को ये माइनस करना है यहां से, 3.2 को यहां से ये प्लस करना है. So we get the range. Do it on the use calculators and all. Do it, and you can stop it. Ikra.